The question is question number 1930 on read code. Let's first of all go through the question. Yeah. Given a string is return a number of unique palindromes of length 3 that are subsequence of s. Note that even if there are multiple ways to obtain same subsequence, it is still counted once. What does this mean? Here in our first test case, we do have A. Sorry, this I do not have. Okay. Now let's see this third example. We do have B, and B. This is a subsequence, which is a palindrome. And if we consider, we do not consider this, and if we consider B, and B, this is also a valid palindrome. But we consider only once. That's what this statement says. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. Yeah, the statement is clear. A palindrome is a string that reads the same forwards and backwards. What is a definition of a simple palindrome is given? The subsequence of a string is a new string generated from the what is subsequence is given here for further. Now this is an example. If we go through the examples, this is a string given. We can have ABA, AAA, and ACA as a palindromes when from subsequence of the given string. Similarly for ADC and BBCB, ABA. Looking at this question, firstly, what do we think of? What the immediate thought we do get? We are taking the subsequence, and we may consider this element or not. What I say is, see, this is an array of n elements. If we consider a position at ith index, we do have two options, either to include it or to exclude it, or not to include it, which intuitively gives us an idea of a DFS, where the code goes in this way. Here, we should not have same set counted twice, right? In the example 3, as we have seen here, uh, so BBB is an example, and BB and using this B, these two are different subsequences, but yet we need to consider it only as one. So to eliminate this, we do put a hash set. We do put a hash set where we store all the valid palindromes here. Now, uh, this is the string given to us. We just initiate a DFS, starting at the index 0, and a string buffer to keep track of a string we are working on, right? Mm. These two are base cases, right? Since when we should have only palindrome of length 3. So if it is of length 3, we do check what's the first and last element, and then if those characters are sent, we just add it to the string, set, and return back. But further, we did not include since we are constrained only to length of 3, we do not work further. So we just return back. Uh, if index is greater than that of string length, then we just simply return as we are going out of bound. Now, for every index, we do have a DFS function call. Then, for every index, we do append the character to string buffer and check whether the string in the string buffer is a palindrome by calling intuitively because we will call it DFS function. After checking that, then we delete the character at that position, and we call same DFS for the next index. Here we include the character at present index and call DFS. Here we exclude the character at present index and call DFS. This will be trying out all three possibility or all ways in which three elements could be chosen from the given string, and returning we will finally return the size of the set, which will as considered constraints over here. It's a temp of 5, so we do obviously get a TLE, right? If we run it, Here we are able to pass all test cases. But when we submit, we do of course get it either some of the other test case. See, this is the one. You see, a huge string is given, we are unable to do it in time. We got really here, so we need to think further ways to optimize it. Um, we are trying every possibility for a permutation of length 3. This permutation of we are trying all possibilities for permutations of our length 3, right? If we consider something of length 3, there will be only three characters. Three characters. So we need to have first. First must be equals to that of third, and the second can be of second can be anything. Second element can be anything, right? So if we further think of this, we can have a predefined first element, first index, first occurrence of a character index, and last occurrence of the character index. And further on, we do traverse from that start index to end index and count number of different characters present in between the start index and end index. Uh, for this, we do run it or bring it down to previously what was your time complexity? It was around 2 power n. Now it comes down to n. Hopefully n. Yeah, hopefully it comes down to n. So for going into that code, this would be that code to here. This part is the code where this is the start index of size 26. We do initiate a complete array with a -1, and end index we initiate a complete array with a -1. And keep updating start index if it is equal to -1, and we always assign index for end index we keep assigning only the last one retains. And traversing for all 26 characters, we do initiate whether it has occurred to check whether it has occurred previously or not. We do initiate this contents array, boolean array, and if start index is -1, it means that there is no occurrence of that character in this complete string. So if it is -1, we do go back to starting of the loop. Else, from start index to end index, if it has not occurred previously, we do increment the answer and assign it has occurred previously to true. So in this way, we do get all possible permutation, and we return answer. So if we run this, errors dot fill start index, comma. Let me go through what are errors. Yeah, yeah, we have also commented function name, right? Now let me check. Passing. This is the end of the function, and the last function last bracket is end of class. This would be a somewhat optimized code than that of previously seen. If we submit it, yeah, obviously it must pass all the test cases. Yeah, this is what we are able to pass all 70 test cases, and we get 88% of the members. Now, if we want to further optimize it, although it could not be that visible optimization, but we do can further optimize it. What are the things we do can further optimize are here in this code. For this also, we need an end of the function. Yeah. So here, instead of keeping storing an index, I just put whether the start index is there or not, and kept updating an index array in between the first loop itself. Right? When we go through the code, we do understand. Right? Here I kept a start index array and an index array. This is of Boolean type to check whether it has occurred previously. If occurred previously, we do not just include that mid element as a starting element, and we do further continue. This is our end index array. Mm. This is just like an iterator to pass come from end of the string, which ei mean end index. Okay, now we are starting at some the start of the string, and if it is not occurred previously, we do set it is true. It has occurred now to true, and till we get a till we get end index of the present character, we keep on iterating from back and keep updating the end index array. Okay, this part is clear. Now, here I have used binary operations to check whether the present character has occurred previously. Previously, we do kept a complete Boolean array, right, to check whether it is occurred or not. Now we are using only binary bit positions to check whether it has occurred previously. Which means if we do have one bit has cell, which means it implies that this character has occurred previously. If I go to the code, it will be more clear. This is the same for loop where previously we have seen from start index to end index, such kind of thing. We are taking the position of the character we get and assigning it to L. And we do shift this one bit towards our left by L times. For suppose if you are getting A, temp would be 1. If you are getting B, temp would be 2. If you are getting C, temp would be 4. In that way, primary bit position is moving towards right by L number of times, right? And if we are doing an AND operation, and if we get 0, which means that previously there is a 0 at that position, so we got AND. We do add a XOR to previous so that previous gets updated with the 1 at that bit position, and further if we do AND operation, we do get 1, right? And then we increment the answer. So this will give you all possible answers, and we return answers. If we run this code, okay, it is able to pass all test cases in sample test cases. But if we submit it, yeah, here we are able to beat 90% of the numbers, right? This is of the more improvement of the previous code. I think further we could be improving, but that we'll see later. Yeah, that's all for today. This is all about question number 1930, right? Bye bye. See you all later.